Today we're here to see an Eiger tutorial. So we're going to go over Eiger. First we're going to review the composite. So we're going to talk about exporting a file, getting a file into Eiger. We're going to talk about fiber strategies and how to lay that part out. Then we're going to talk about metal. This is basically going to encompass the digital forge, so we talk about one big ecosystem of how simple it is to go from composite to metal. And then we're going to talk about the ROI starter kit. And then finally we'll do an interactive Q&A. And if you guys stick around and you guys want a free part, we'll be offering a free part to everybody here at the end. So let's get started. We've got our part in SOLIDWORKS. Eiger is CAD agnostic. I'm going to go over just some export settings, kind of my favorite export settings, and just so everybody kind of knows where I do that, and then we'll get this part into Eiger. So first thing you want to look at your part, especially if this is a part from somebody else, we want to check our units. So this part was designed in millimeters, so we're going to need to know that when we export this file. So we're just going to do a simple save as, and we're going to change this to a STL file. But before we just hit save, we want to check the options here. All right, so I typically leave these at custom. So depending upon what I'm trying to accomplish, sometimes you may have to pull these one way or another just because it's creating a gargantuan file. So notice our units are off. So we want to change that to millimeters. Deviations, I'm probably going to leave that where it is for now. And then my favorite export setting is ASCII 2. I just like this because I can export a multi-body solid. I can just do a single body out of that. So it's just a nicer setting in my opinion. So we're going to hit OK. So now we've got our file. Now we want to jump over to Eiger. So Eiger's a web-based slicer. Runs right here in Google Chrome. So you see I'm running this right here. The fantastic thing about this is there's no thick client to load. You're not worried about versions or the latest and greatest version coming out. And oh man, I got to load that thing up. Every time you open this, it's the latest version. So that's fantastic, and it's a great digital repository. This is where you store all of your files, and your entire organization works out of the same interface. So it allows you to kind of see what everybody's doing and collaborate here as well. So we saved our file out. We're gonna take this file. I find the easiest way is just kind of drag it over here. So we're just gonna hit import. It's gonna bring this file in. So this is where I left my settings at freedom units, unfortunately, so I've got to change this back over to metric, because remember we exported this as metric. So we're going to turn this into metric. This is what it looks like as I initially bring my STL file in, okay? So probably don't want to print in that orientation, so we're just going to click the face that we want down facing. So that was easy. Just completely reoriented the part. So now we're going to pick our material. So for this one, we're going to pick onyx. We could do this in FR, ESD, nylon white. Notice we even have steels. So when we start our conversation about metal, we're going to come back to this. But you see how easy it is to change our base material. So base material of onyx, and then we're going to pick our reinforcement fiber. So for this one, we're going to pick carbon fiber. And then printer, we're going to put this on our industrial machine. So at this point, I kind of like to hit save, so I kind of have an idea. So as I hit save, it's going to propagate our print time and material cost. We see initially our print time at 6 hours and 45 minutes with a material cost of $11.36. Now, we just blindly accepted the defaults for everything, and we're going to customize those here in just a second. But the way Eiger works is it assumes that there's a rectangle out there, and it works off the principle of a sandwich panel. So it puts fiber in the bottom, fiber in the top, and we're going to go back and customize that. So for basic settings, this is where we set our units just a minute ago. We do have some turbo features, turbo infill, turbo supports. The caveat on these is they don't work with fiber, so that's how you get a super fast part for fit and form. We're going to jump over to infill. This is where we would define the infill inside of that part, whether it's triangular, hexagonal, rectangular, gyroid, or if you wanted a solid fill part, this is where you would define that. So fill density by default is 37%. What we'll tell you is this is a fabulous place to start. So if you don't know where to set your part, just leave this where it is. Roof and floor layers are exactly what they sound like. Up facing, down facing layers, we're doing 4 at a time. Wall layers, 2 at a time. We're going to leave those where those are. Let's talk about reinforcement. So this is where it went ahead and put the fiber in. So notice it did 8 layers. So that's 8 total layers. That means 4 on the bottom, 4 on the top. Those are derived from our fiber angles. So by default, it twists 45 degrees in each layer. So it prints at 0 degrees in the first layer, 45 at the next, and so on. Now, no fiber can be put in exterior layers, and that's how we control the surface finish and the accuracy of the part. So there's 2 methods to put fiber into your part. There's concentric, which is exactly what it sounds like. It will go around the part. And there's a couple ways to define that. So you can go all walls, outer shell only, or inner holes only. We're going to look at this a little deeper here in just a minute. And then by default, it puts isotropic fiber in. The reason it does that is isotropic fiber is the strongest fiber strategy. And it's basically going to put 2 rings around a part and then fill it full, a zigzag pattern in between those rings, twisting 45 degrees every layer. For now, I think we're good for this initial setup. So what we're going to do is we're going to jump over to the internal view. I like to call this the Xray view. So we can kind of see through the part. And what this does is this defines everything that's going on inside of the part. So first things first, for visibility, I'm just going to turn support off for now. Everything in here in this screen that's purple is support, so I'm going to turn this guy off. And then everything blue is secondary fiber reinforcement. So we see this fiber up at the top isn't doing us a whole lot. So let's jump into customizing this fiber. So across the bottom, you'll see the life of this part. So all the way over here on the left is layer 0, and all the way over here is the last layer, top layer in the part. These blue groups are our fiber. So for now, what we're going to do is we're just going to get rid of this group at the top because it's not doing us any good. We're going to go into some customization, and we may end up putting that back, but we'll see how it turns out. This part is a little harder to see in this view, but remember it's got this flange here, and this is a definable geometry, right? So in my mind, this is I want to reinforce this base flange because this is where this part would be bolted down. So I'm just going to jump over to 2D mode, and now I can scroll through here, and it's going to show me everything that's going on in each and every layer. So we see here's the first base layer. Now remember, you can't put fiber in your exterior layers. So but now we jump into fiber. So 45 degrees, 45 degrees. So there's our base layer. That's good. So now we're printing sparse fill infill in a triangular manner. So what we're looking for is the top of that flange. So we're going to scroll across until we find a ceiling layer. So there's this first ceiling layer. So what we want to do is back up right behind that, because remember we can't put fiber in exterior layers. That's layer 56. So I'm going to jump over back to 3D mode. I'm just going to pick a group. We're going to create group, and then we're going to check use fiber. Now when we check that, it's using all the fiber settings from that previous screen where we set that. So notice our group is layer 58 to 49, so it was 56. And then we want to kick that down to 4 layers. So we're just going to pull that out like that. I like that, so we're going to hit apply changes. So now it's going to go through and update that part in the part view. Notice, guys, as every time I change this, your material cost and your print time is updating, right? So now we see that we've got a panel on the bottom and a panel on the top. This is our traditional sandwich panel type design. So Now let's look at these holes. So we've got this counterboard hole here. Let's go in and kind of do some reinforcement into this hole. So I'm going to jump back over to 2D mode. And actually, I want to back up and I want to find where that counterbore is. So we see the ceiling in that counterbore. So I'm going to go one layer behind that. So that's layer 29. And I'm going to do another create group, use fiber. I went the wrong way, didn't I? So let's jump over here to 29. And then we're going to make that at 4 layers. We're going to hit apply changes. Okay, so now you can see I got a reinforcement at the bottom. I put a reinforcement panel just below that counterbore so that as we put a bolt in there, it's going to be ultra strong. So now we're going to work on the compressive strength here. So I think I want another layer in here. So let's just go right here. We want to create another layer. I want to hit create group, use fiber, but I want to change the fiber. So instead of isotropic, I want to go concentric. And then instead of all walls, I just want inner holes only. And then I'm going to move this up to 4 rings. I'm going to hit apply. So what I'm doing is I'm reinforcing that hole, right? So as a bolt comes down and you get some compression strength on this, that's what we're looking for here. Now, let's look at the top of this part. So as I look at the top of this part, there's a few different strategies. There's not what I would call a definable geometry that says, hey, reinforce me, right? So there's a couple different strategies we could take. This part is theoretically a needle bearing housing. So let's say we were going to do kind of a fit form function test before we went to, say, metal, or before we began to cast this. We just kind of want to verify everything. So we might want to reinforce this barrel right here where that bearing would go. So in that case, what we would do is we just kind of, let's pick this whole group. We're going to hit create group, use fiber. And again, I'm going to change this from isotropic to concentric. And then I'm going to go to inner holes only. So now that we have that, I'm going to hit apply changes. All right, then usually it's a pretty good idea to, once we get this far into it, just reach over here and hit save. We just kind of want this thing to rebuild everything, make sure we got it saved. Okay, so now we're seeing this fiber strategy. So we've got all our panels down here, we've got our reinforcement. So now look at this, we've got this barrel reinforced. So this is where we could then print this part and then take this, press this bearing in, and then go and check, is this gonna work for a final application? No, I don't think so, but this would let us do a fit form check. So next thing, so let's say that's not necessarily what we're looking for. We need some reinforcement in all of these geometries that we're seeing up here. Again, there's no definable geometry. So in that case, what we would do is we take this whole group, and instead of entire group, we're going to change this entire group to stripes. And then I'm going to change this back to isotropic. I want this back to 2. And then we're going to put 6 layers, 4 layers each. So I'm sorry, 6 stripes, 4 layers each in this part. So what it's going to do is just going to stripe this part. So this is a strategy we would use if, again, like I said earlier, there's no geometry that just screams out, hey, I need to be reinforced, but we know we do need some reinforcement across this part. So what this feature does is it takes that whole span and then equally spaces stripes of fiber across it. So we see what we've done is we have reinforced all of the geometry all the way to the roof. So that's a pretty good strategy to get a fabulous strength. So we're going to hit save. We're going to let this thing rebuild right quick. This will give us our full. So if you look here, here's your print time, 8 hours and 29 minutes. and at a material cost of $29.28. So we're going to jump back over to part view. Now we've got this part completely configured. Now we're ready to print. So we're going to hit print. We define our printer, so which printer in our organization we want to print to. And let's say we need 4 of these things. So we're going to hit just add part. It's going to come up with this part, and we're just going to click on it a couple more times, and you see it now has a quantity of 4. So it uses an algorithm to place these out there, is kind of nests those, right? So, but we can drag these and place them anywhere we want. All right, so now it's given us, this is a full time for 4 parts, right? Now we're ready. So let's hit print. So it's just saying, hey, make sure you've got enough fiber in your machine. So we get a couple options. Okay, so it's telling us how much plastic, how much fiber. This is where if we know that we don't have enough of these materials, we'd probably just hit add to queue. Even if we hit print now, the machine's going to stop and say, hey, I don't have enough material anyway. So we could hit print now or add to queue, doesn't matter. In this case, I'm going to hit add to queue just so we can go look at it. So it's going to take, and it creates a build file of these 4 parts together. So it's just creating a slice file for all 4 parts. So once this is done, we're going to go look at the queue of the machine and the history of the machine so you can see how that works. All right, so our file went out to the X7 machine. So you see that we've got 488 cubic centimeters of onyx left. Somebody loaded fiber but didn't enter the weight. So we definitely need to go and check that. So we see that the file is sitting here in the print queue, and you see the history of everything that has ever been printed on that machine. At this point, we would go to the machine, kick that print off. What we're going to do now is we're going to jump back to the part. All right, so that part's printed. We went through all the design iterations. That part looks like it's good, so we're good to move to metal. This is where we configured it initially. Here's what we're going to do. We're going to print this part in 17.4 stainless steel now. So we're going to change this material over to 17.4 stainless. Notice the part got slightly bigger. As you define a metal in our software, it automatically adds the appropriate shrink rate for that particular material. So we changed it to 17.4, and so it automatically changed that part, added the shrink. So now we're going to jump over to settings. We have the ability to print in either 50 micron layers or 125 micron layers. 125 for the most part works fantastic. Units are good. As far as supports, this particular part doesn't have a ton of supports. It has a little bit around the inside of this barrel. So we wouldn't necessarily change this, but we do have the ability to change the supports in a cubic manner. So it would essentially build those supports in cubes with a ceramic in between, so it would break out. This is designed for a larger volume part with a small opening. This would allow you to basically shake the supports out of the inside of that volume. And then radial separations. This would be something like an O-ring groove around a shaft. You would put a radial separation in there so that it broke it in pieces and you could get it off post center. So we're going to leave this at default. For this one, we're actually going to turn the raft off on this part. A raft would be if you had critical geometry touching the build plate. As that shrunk across the floor of the furnace, it would throw your hole-to-hole centers off. So this part is big and heavy. We don't need the raft. For infill, this is where you would define, hey, I'm going to use triangular infill. So that infill that you're accustomed to seeing inside of a plastic part, this is how you get it inside of a metal part, which becomes significant when you're talking about weight savings and stuff like that. We know that infill is typically as strong as solid in most geometries, just uses less material and it's faster. So if we wanted to print this part solid, we can go and do that. We can as well do gyroid infill in metal. So for today, we're going to leave this at a triangular fill. There are applications where you want to do exposed infill, so that would allow you to leave floors and ceilings off if you wanted to. We have quite a few customers who do this. Roof and floor layers, this just defines your post-centered wall thickness before you get into the infill. So for this one, we're going to knock it up to 1 millimeter. That gives us a 1 millimeter all the way around this part. So we're going to hit save. It's asking us to overwrite because we set custom fiber initially on that first part. So now it's going to come up with a few important things, right? So it's going to give us our print time, our wash time, our dry time. It gives us our part mass, and most importantly, our material cost. So this is the cost in stainless steel filament to print this particular part. So now we see it's an 11.5 hour print time. It's going to take 9 hours to wash. The wash is a chemical debind process. Dry time, it's an 1.5 hours once it comes out of that wash, just before it goes into the sinter. And then our sinter is approximately a 26-hour sinter for stainless steel. Now we're ready to hit print. The print process is pretty much identical to the composite. You can add parts. So if we need to add, say we needed to print 2 of these guys, puts these in here. If we want to move them around, we can do that. Once we hit print, we can just add it to the queue. All right, guys. So that's pretty much it on a quick overview of Eiger. If you guys got any questions, you want a full-on demo, you want to dive a little deeper into this, definitely reach out to us. We're here to help you through the process. I do want to mention something about security. I know people are concerned about security of a web-based slicer. This slicer is ISO 27001 certified. It meets all US DoD regulations for encryption. So if you want to dive deeper into that one as well, definitely reach out to us.